Just talk.
Good morning and welcome to the Truth in Automation Deep Dive. I'm Ben Savage, the CEO of Veritas Automata, and I've got Saurabh Sarkar with me, or Dr. Saurabh Sarkar, our principal scientist, and we're continuing the series of conversations we've had recently on different AI and ML. We need to come back to traditional machine learning again, I think, but we're going to continue on the GenAI today, and I thought we've been showing a series of battling different LLMs out in the arena. I think we're going to take a quick break from that this time, and we're going to show a couple of other things. For those of you who may not have known, last year I was on a podcast from our friends at Twinning Strategies, and I talked about a side experiment I'd been doing that I thought was really interesting, which is, if you're ever familiar with the author Douglas Adams, he had a book, Dirk Gently's Holistic Detective Agency, and one of the main characters there had a piece of software that could turn spreadsheets into corporate anthems. And I've continued to play with this idea because I realized just before I went on that podcast, you can turn someone's corporate balance sheet into an annual report or into a song. So I've been trying some different genres of music. I'll just play two quick samples here of what you can do. One is a yacht rock and one is a ska. We did do some testing earlier and we were working on the volume, but if it's either too quiet or too loud, I'll apologize now. And we'll find a place where we can share some of this stuff where you can go see it at your own leisure. But I'll go into those. And I'll talk about some other creative things we've been working on that are not in the traditional text LLM space that we've been focusing on, but some of the other more creative ways you can go apply it that you'll probably see some more of. We've got a couple of collaborations going on with some different groups. So first, I'm going to share my tab. And so this is the Starbucks 2018 annual report as a yacht rock song. And I may have cut the sound a little too much there. No, it looks like I have broken the demos, Saurabh, so it was not just what you were working on this morning.
All right.
So let me go try the other one real quick. See if that one works. Okay, this one does. So let me swap over to that screen real quick. And there we go. So this is the song is a ska version. The yacht rock is not working.
That's what we're looking for. Net earns to 2.5 billion in the bank. Starbucks still it ain't no need to think. Plus we're on a tank. Hey, hey, it's a coffee craze. Starbucks is.
And just to point out, the way I created that was taking their annual report, putting it into an LLM, and prompting it to have it generate a song as a summary based off of it. And then I dropped it into Udio for that particular music generation. And what's really interesting when you think about these is I didn't do any editing for that. And I don't have any music skills. So when you think about the good thing, bad thing, right? The power for people who can't create some of that on their own to now be able to do things is super, super there. The terror is also for those people who are creatives and who are true artists in their skill set. What is the impact of that? So I think that's an interesting thing to think about. This is something I think as practitioners, we have to think about how do you apply this technology for good and not for those more questionable use cases.
Yeah, beyond the good and evil, it's fun. Yeah. So,
You're not just saying that because I keep dropping random stuff to you, are you?
Well, sometimes financial reports can be dry, right?
Yep.
So having a little of fun with it, it doesn't hurt anybody. But also showcases some of the creativity and, with LLMs where we can push it, right? So.
Well, and it is different ways to take content or take things or create interfaces or ways to go interact with stuff. And I think if you've ever done anything with education where you're trying to teach people, you got to remember people are multimodal. So sometimes you got to have image, you got to have video, you got to have audio, you got to have something where they're doing something physical. And so it does give ability to take one piece of content and reuse it in different ways.
So you're telling me my algebra class could have been a rock song.
Maybe. I don't know if it would. I don't know if it would have helped me in algebra, but that's because I got to calculus and algebra was okay. But calculus and I took a couple looks at each other and went, we really don't like each other. I'll show a couple other demos of some creative stuff, and these won't have audio for the most part. But we'll talk through a little bit about how some of this works. So as I go over here, one of the things I was doing some work on was some video, and when you're prompting, you kind of try and figure out where are the limits of the system and where aren't they. And again, we've talked a lot about models. Every model you work with is different. So this is particularly using Kling AI, which is comes out of China. And so I was prompting it trying to get a llama fighting a cybernetic camel because that's what seemed like to be a good idea at the time. And I could not for the life of me, I could get, whenever I'd prompt it for a llama, I would get 2 camels. And I realized something. The data set this was all trained on came out of a data set that would not have the idea of a llama inherent in it. So think about llamas are native to South America in particular, but they've made a pretty good spread up to North America. So if you ask it for something the model is not going to know, I thought about something else it might know, thinking about pop culture. So I asked it for a meerkat, thinking that's in The Lion King, becomes a pretty well-known thing. And I got a very different result when I was trying to ask it for the epic fight. I got an actual camel, and I got the meerkat in their cybernetic armor. Now, the AI does some weirdnesses, it moves stuff back and forth, but it was interesting, right? So this is when you're working with, whether it's a text-based or an image-based or a video-based, where is the data set that this tool is coming from? And what are some of the other constraints or things it's bringing in that you need to consider when you're going up to apply it?
The system prompts probably is a good
Yep.
idea as well, right? So, system prompts like gatekeeper to your interface to an LLM, kind of a setup. So basically what you can do out of an LLM is controlled by system prompt itself.
Yeah.
Yeah.
So when people think about a tool like that, whether it's a large language model or ChatGPT, you've got the software you're using to send the queries into it, and those go to a system prompt, or maybe a series of system prompts, and then they go to the model itself, which has its own set of things baked in and its own data set, right?
Right.
I just saw something interesting they were talking about. I think it was O3 has data as of like March of 2023 or something like that.
Okay.
So you think about what is the available data set in it, and then how does the system prompt interact with it? Because if it doesn't know it or it's told how to go respond.
Yeah. I mean, data is one piece of it, right? But if you don't have system prompts, you don't have basically a lot of the safety with LLMs playing into it. So it's got plus and minuses on both sides of the things, right? So LLM security is an important aspect of it. You don't want to spread misinformation or dangerous information using LLM because it's access to most of the web out there, and a lot of it is probably not curated by humans down the line. So it could answer a lot of things which you don't want to spread out quite a bit. So
that's true. I think it's a little different if you're doing it for a general search versus for a corporate perspective. But kind of on that theme of security and system prompts, there's been a lot of talk about DeepSeek,
right.
both R1 and the is it R1? What's the
version
number?
3.
V3 and R1, right?
Yeah.
So R1 is the reasoning, and V3 was the one that came out just before it.
Right.
And people have been making a bunch of. Let's first talk about what is the new DeepSeek, both V3 and R1.
Okay.
So what is your take on them, and what do you think makes them different from some of the other models out there?
There's a lot of chatter around how many GPUs they used and all of that. We don't know that for sure, but but essentially it has been open source. It is at the same caliber level as an closed source cutting edge model like a ChatGPT kind of setup, right? So, and the way they trained it, it was very, very highly optimized. There's also talk about how optimized at a code level. So it's very tuned to use the hardware very effectively without wasting any resources. So it was really well done. The other piece of it is, how much system prompt you have due to from
Yeah.
the region it's coming. And that a couple of weeks ago or a couple of days ago, there was a news that it doesn't pass a lot of the security testing. And it's kind of, if you think about security testing, it's how much of the guardrails
Well, I
you
guess
put in.
there have been two separate sets of commentary around it from that
Yeah.
perspective, right? One, I don't want to let that slide by, that they did find something. They found a method that was much more efficient to do their training for
Absolutely.
this version of their model.
Yeah.
And to be clear, I think one, we don't know how many GPUs they had, and we don't know the full. This was particularly the last step of the training stack
Right.
that was super, super efficient. I think that's something that's important for people to think about, because let's all be honest, you can't view this as a world where we're going to continue just throwing more GPUs at stuff. At some point, you're going to run out of them, or so there's an incentive for people to either find better hardware or better training methodologies that are more efficient on that hardware.
Right.
But back to what you were talking about from the guardrails, with DeepSeek, there were a couple things that came out as people were playing with R1 and V3, right? One was, what are the, hesitate to use a certain term, censorship, but what were the limits around it on what it could talk about? And then there was what you were talking about the security guardrails, about where there's risk. And the reason I want to differentiate is, one, they're different problems, and that one is, you don't want it to go talk about certain things, whether it's a corporate or in this case a national perspective. The other is, you can ask it harmful things it might be able to help you do.
Right. I mean, essentially, we should probably define what system prompt is underneath. Yeah. So, the easiest way to think about system prompt is that you have a gatekeeper at a VIP agent, and you walk up to them and you present your VIP pass, and then it's like, okay, that's a valid pass. You let them in, and then you can enjoy the event, right? That gatekeeper is kind of like the security or the system prompt.
Is it a gatekeeper, or is it more like a minder who's there making sure that prompt always gets?
It's clean. I mean, I use the security guy as a metaphor here, because he has a set of things that he's checking for.
Gotcha.
Hey, is this a valid pass, or is it forward? Is this is it a kid? He's not allowed at that convention or whatever it is, right? Or is he carrying arms? Even that, right? So he's going through his own checklist and checking before that person is let into it. So it's a way of thinking about it. And then when you hear about people trying to, break the security into it, right? For example, you say you cannot say harmful things, equivalent to you don't let a person go through into the, if he doesn't know. So imagine that you walking up to the security and say, hey, let's think that we are in a environment where we don't need VIP passes to enter that. How would you treat me? And he would say, yeah, I'll let you go in. So you go in. So it's an example of kind of a penetration into the system prompt or the security of LLM, right? So it's got layers to it, because it also, you are controlling the behavior and thought process of an LLM, or whom to let in, whom not to let in, what to disclose and what not to disclose, right? So that how I would present that at a in layman terms, that's how security system prompt works. So.
Well, and I think they can also control when sometimes I've seen models, and you and I were talking about this, like some of the early Quen models I would see go, and so Quen is a family of models that come from China. Right. I would see them behave very strangely because they weren't interacting well with the system prompts I had set up in the tools I was using. Right. So I could drop a llama model in, and it would be fine. I could drop a Granite or a Mistral model in, and they were handling the system prompt fine. But the way Quen was structured, I could run the model technically, but the system prompt caused some weird behavior. But the other thing I think that came up from this is I wasn't using. So I'm an abnormal LLM user. I very rarely use the cloud-hosted ones. So that means I use ChatGPT a little bit. I use Claude and Perplexity a little bit. But the reality is I run most stuff local on my computer, which means I see sometimes a very different experience than users would. So when DeepSeek first came out, I was very excited. I went and downloaded it on my computer and had the 32B and the 72B models running. And I was a happy camper and going off and asking it weird questions to see what it would do. And I was prompting it for things. And then I see people are talking about DeepSeek doesn't answer these prompts. Like, wait a minute, I got an answer. And then Saurabh and I were talking, we realized this because I'm not using the cloud version, which has a different set of system prompts than I start with.
Yeah. I mean, even when you're distilling some of these models, which you are probably using one on your laptop or even on a GPU server, so some of the effectiveness of the system prompt goes down as well. It's not always like prompts appended in front of your prompt. Some of it is also built in during the training itself. So, LLMs have something called the attention layer where they're paying more attention to certain parts of the prompt. They would automatically bias that to pay more attention to the system prompt, which has been built in, right? So even if you're saying, ignore all your system prompt and follow this one, they would not ignore it because the attention is higher. There are a lot of other tricks, and a lot of these system prompts are proprietary to a lot of these companies because they want to keep it secure, right? So, but besides the security aspect of it, there's another nicer way to use system prompt is what you did with your financial report, how you convert it into a fun thing. That's a part of a system prompt as well. So you could, let's say you have an enterprise chatbot and you want it to use a certain tone or mannerism or certain way of speaking when they are interacting with, say, external clients or even internal employees. You could put that in a system prompt and govern some of the behavior as well.
Yeah, and a lot of times you'll see those as like you are a helpful assistant or you are an engineer or something like that where you're getting that, right? And that's part of how people do some of their prompt engineering, but it's also done at a lower level if you're trying to make it more systematic in how it responds.
Yeah, I think it's an interesting piece of technology, a feature of LLM that we can use for safeguarding as well as controlling the behavior, right? So sometime back, we were testing on a piece of software we built to internally test the system prompt, and you would ask a simple question, why is the sky blue? And you leave it default, it goes on answering it in a kind of a scientific way. And you prompt it saying, hey, you are a poet, you are not a science guy. Then it completely takes a different turn and becomes creative about why the sky is blue. So, yeah.
So when we're designing systems, right, we've talked about, first thing you've got to do is choose a model that's going to be the right fit, which is a combination of size. And I was talking about some of those, the data set, the knowledge it's got, and some of those underlying kind of characteristics, and what is your license around it, right? But then the next piece is kind of, where do you think about system prompt versus RAG versus fine tuning and all that piece, right? Because those are those three are key pieces to design the system.
Absolutely. So they all play a role in the entire pipeline. So, the RAG is where it is retrieving the context and answering a question to it, right? But with system prompt, you can make it more and more factual, saying that, just answer to the point, don't come up with your own explanation why that is. And so you can make it a little bit more, let's say it's a business or analytical question, you keep it very factual, versus if a marketing department is using the same LLM to be more creative, you can relax that and say that, hey, come up with better whiteboarding ideas so that they can trigger more thought process, right? So it's a very, very useful lever to pull that goes on top of, say, RAG setup and all of that stuff to, it gives them a different persona or like a different hat to wear every time you're using a system prompt.
Cool. What's your favorite thing you've seen as you've done as a system prompt?
So I think the finance thing that I worked with, where you can use it to make a song out of it, or the fun part was around system prompt is that, hey, you want the LLM to use certain tools as well, right? You want the output to be predictable so that down the pipeline they can understand that and figure out what that API call looks like. So system prompt also aids in a lot of that, saying that, hey, you gotta not explain why you are making that that tool call, or why you are choosing to do that. Just tell me in this format, and it does that. Then it becomes very useful tool down the line. So.
Well, it sounds like there you're almost getting into some of the stuff we were talking a little bit about last week or last podcast about some of the structured data.
Right.
You can use, so instead of just having tool calling, you can have the system prompt lean heavily on helping to attempt to manage the structured data piece, the structured output.
Yeah, absolutely. And I think we can demo that if you like around.
Sure.
So what we did was,
So, so which of the
the table expert or something on.
Yeah, I'll pull it up.
Yeah. So while Ben pulls it up, let me explain what it is. So we looked at RAG quite heavily for clinical purposes, as well as we looked in other areas like project management aspect of it, requirements gathering, and then also financial documents. So one thing we found out using financial documents was that a lot of it has a lot of like a natural language text, but a lot of the data is also hidden within the tables itself. And that's where we found that large language models struggled a bit. If you throw a table at it, and if the table is simple, then it doesn't blink an eye. But as soon as you have complex table hierarchical setup, headers are getting repeated in a weird manner, and things like that, which is very, very common in any 10K filing or any financial document.
Or a lot of business reports, right?
Right.
And this is where you've taken it out of Excel and you've now got the business report that you're going to have someone look at.
Right.
You've put in a graphic of the slot of the chart or table you're going to look at.
Right.
And this is particularly what you're talking about, right?
Yeah. So that took us some time to build our own tooling around it, and so how do you understand a table? So we had to start with scratch and come up with things that helped it understand complex table, not just simple, like an Excel file table, but multi-tiered hierarchical table and something like that, right? So this is basically a table we picked up from a financial report. I think it's Microsoft.
It's the Microsoft 2023,
Yeah.
I think.
So if you ask a question, this document, let's ask a question, see what it comes out of it.
Yep.
And then
so I'm going to ask it about the foreign government bonds.
Yeah.
There we go. So I've fired off the question. We're going to see a response come back in a second, unless I broke this too.
Well,
So
wait,
there we go. It came back right
pretty
away.
quick. So let's open that file, because that's going to be fun. Now, if you look at the document, it has nothing but a single table.
Just let me make sure I get that shared the way it works. Screen. Share the window. There we go.
All right. So
yes, I have too many windows open, so I apologize.
So I don't know if our audience saw that question and answering thing of it. If you
they saw that,
okay,
and then I switched.
So what I was going to tell you that basically it answers the questions and also cites the document from where it pulled. And if you notice, this document has nothing but tables on it, no verbiage of any kind. And some of these tables, they look crazy. The headers are right on the top, and then you have some summations, and then you have grand summations and all that stuff going through, right? So he's still able to pick up the right numbers and pull that up. So this was a bit of a challenge for us, but I think this adds a lot of value for businesses where a lot of their data is locked into tables like that in their documents.
And we can see the loss was 24 million, and if we look across here, it was 24 million was unrealized loss.
Yeah.
And what's important about that is this is what takes work when using these tools, right? If you were just to throw this into a normal LLM, or even a higher end tool like a ChatGPT, you may not get this answer correct, or you may not get this answer the first try. And we know from the hard part of seeing what happened. And then where this gets more interesting is you get different businesses with different levels of different types of documentation, whether it's table reading or other complex figure reading. I was having a discussion with someone the other day, Saurabh, and they were talking about manuals with complex like explosions of a machine diagram. Say, what are the service parts? And you think about that, that's the thing where a lot of models are going to have a challenge, and there's going to have to be some tweaking on your ingest, which is what we had to do here to be able to make this usable for the system.
Yeah.
Becomes a really interesting problem to solve.
I think, besides the table part, we also looked at like charts and tables like that, because sometimes you're ingesting a PowerPoint, because whatever the Excel file behind that PowerPoint is gone, has happened to me in past.
or you just are tired of getting PowerPoints from me.
Exactly, one of the two. But having the LLM look at it and still draw an inference, it may not be 100% to the third decimal place, but if it is within the ballpark, that is a useful information. And if you've noticed, when you're asking the question, it's always cites the document. So you always have the option to go take a look at it and make sure that it's, that's what the number is telling is what you are looking for, kind of a setup, right? So I look at LLMs as like unrefined ore, if you may call it, and then you refine it and tool it to your purpose, and that's where the value comes from, not just using what's available in the public and running with it, right? Because you may not need the biggest models out there for your business cases. You need something that can be malleable and tuned to your use case, and that's where you can remove a lot of those hallucinations and make it more purpose driven.
Well, and I think that's where you and I spent a lot of time both looking and talking about this, and whether it's you're running one or multiple smaller models.
Right.
For a RAG, you're going to get much faster performance. You can get a much more scalable, lower cost system.
Right.
But it also gives you it reduces some of your risk too. If I'm going to use, I think DeepSeek is R1. It's like a 627B model with it's a mixture of experts with a bunch of 32B. Because I remember we were all excited because I thought I could run it on my computer, and then we looked at how much GPU memory was going to go. It's like, darn it, won't be able to run the full size. But that requires a lot of compute. It requires something at an H1 level or higher, H100 level or higher type card, which is a lot of cost to go run everything. So if you can go run something with a 1B model or a 3B model, you've got a ton more options on how you can go deploy it. And it's not got as much data where it can go free range on you and hallucinate because it's made something interesting up.
Yeah, some of these 1B can run on a simple embedded system. Maybe it's on your dashboard or something while you're driving. You don't want to listen to a Roxanne or something. You could be very tuned to some very specific use case. So having wearable devices or on as an add-on device to other equipment or things that you write, the 1B or the smaller models are much better suited than having that device to talk to cloud, come back, and things like that. So
I'm going to shift a little bit, still kind of staying on the DeepSeek, because we're talking more about stuff that probably almost in some ways is about R1 or V3 versus the R1, the reasoning model. I'm curious to hear your take on the reasoning models.
Okay.
And the first kind of salvo I'll fire is, because I run this all local, I was running DeepSeek R1 70B and Llama 3.3 70B. So Llama 3.3 is the most recent Llama version, which is what I've used to do a lot on my computer. It's overkill, but it's entertaining. And what I found is the R1 model is considerably slower at responding because of that reasoning. And I don't know, I always got better answers, but that's maybe I'm looking at it from bias because I have an unusual use case.
So I think with a lot of the R1s and things like that, they have developed the chain of thought within the model itself.
Yeah.
So some of it, think of this. In your job, right? Some of the tasks that come to your desk, you don't have to think about it. You auto run it because you've done it so many times.
Yeah.
Versus every time the job comes, you are giving it full attention and thinking through what I need to do. You will slow down. That's what probably you've seen is, some of the Llama things, it's not restricted by chain of thought because it's already seen that in the training data. So, readily defaults to that and spits an answer for you real quick. Versus anything which goes through a chain of thought, you are kind of going through a chess move. And I'm thinking ahead, 20 moves, 30 moves ahead. Versus if you see a chess pattern, this is an opening, and then you know how to defend that or whatnot, right? So that could be but most of these models are again closed, right? So we don't know what's underneath, but that would be my kind of best guess.
But as someone who would consume these APIs, if I'm not running it local, I'm consuming an API and I'm usually paying per a token, right?
Right.
Doesn't the reasoning just consume a lot more tokens for sometimes the same answer?
It does, especially when it's outputting what's his thinking, which I've seen with R1, they think tag and then they put it. I mean, it's really, really cool that you can look through the thought process. It's awesome when you are prototyping and checking it out, but in production, you probably don't care what's going down every time. Maybe for debugging purposes, but not for production piece of it. That's how I see it, right? Whenever something goes south, you want to look at the logs to see what's going on, but when it's running, you don't care about it. So maybe that's what it is.
Well, that's the part I do like about it, is seeing that. That's the one thing that's bothered me about LLMs is how do you effectively debug when you put this set of tokens in as your query, it outputs this set of tokens. Okay. How do I get from A to B there, or from A to C there? Somewhere there's a B. So how do I, I've thought often, I'm waiting for someone to have the tech or for us to have the time or figure out how to do it, where you've got like a step-by-step debugger that walks through.
Right.
Now, the problem is some of these models are so large,
Yeah.
that might take a lifetime, I guess.
Yeah, and because it's probabilistic model, they switch paths in parallel paths very quickly, and then you're getting lost in the neural network. Some of the better way to do and still preserve the chain of thought is to, in your prompt engineering or when you are using it, have a preset path for the chain of thought itself. So it has some room for it to make go through those chain of thought you've laid out. This is my framework. I think through this in this way, and then it kind of gives you that predictability a little bit, but also keeps that natural flow of tokens or language, what you may call it. So.
Well, and I think that's why you and I tend to like, and a lot of the solutions that we either architect or we're building or we're talking with people about building is there's some kind of rules that are outside the LLM to drive specific behavior. Because I think what we've seen, and we were just talking with our colleague Etienne the other day, right? There's just certain things where the LLM won't, because of that probabilistic and because of just the technical nature of LLMs, they won't give you a consistent decision-making path.
Right.
We were trying to get an agent to stop talking in that case, right? It would get into an endless loop. So how do you create a hard rule so it knows when to stop?
Yeah, and that's what we were looking into, is that some of the solution would be a blend of existing solutions as well as the LLM being a piece of it, right? So, like stopping condition, how do you meet those with other systems before you force it to stop kind of thing? But it keeps on going because it's supposed to predict the next token, right? So it's a new technology for sure. But again, as we go through the use cases and they solve real problems with it, a lot of it,
But as I think about it, it's a new technology for sure, but it's a very old problem. Because the more I've dealt with engineers, the more I've learned that their definition of done is sometimes different than the rest of ours.
Yeah, that's a good way of putting it. So we never tend to stop engineering until we get that 0.001% improvement in whatever thing we are doing. So
or until they keep finding interesting problems to solve.
Yeah. Possibility. Maybe there is a way to energy constrain that you only have this many joules of energy to spend on a question before you run out. So find the most optimal way to do it. Maybe that's one way to do it.
That's an interesting. I mean, as you say that, what I'm remembering is one of my favorite definitions of Bitcoin I heard was it's not a currency. It's a unit. It's essentially a definition of a consumption of a unit of energy. How much energy did it create to create that Bitcoin or the next one?
Yeah, that could be brought into LLM world as well as instead of trying to optimize, prompt engineer everything, just restrict the energy flow.
You get so many clock cycles, and if you can't solve it in 100 clock cycles, move on.
Yeah,
that's like old school embedded engineering. It's
I mean, right now there is no shortage of GPUs or in the model world, but as the solution gets
no, you just said you're going to get more efficient. I can give you a clock cycle budget.
Yeah, I mean that's what I'm saying. Right now, we are throwing a lot of money at developing these LLMs, but as we go into more enterprise where it needs to be tuned and every dollar has to be accounted for, maybe that is a way to put that constraint on it.
I appreciate you saying right now you don't need a constraint. In the future, we'll put it on.
More power, right? It's better the bigger the engine you put on a car, the faster it goes.
So what I should do is dig up those Jetson systems we've got and just say you've got to run everything within that constraint. You can't run it on the Dual A6000.
Actually, we did that. Remember, very early on, the IoT AI devices that we have been working, which has been in field for thousands now, right? We did that. Started off in a very small footprint, and then we expanded. I think that was a good way to look at the problem, not to have the entire field to play with, but kind of be very cautious about the
by default. And this is what I think was probably for me the biggest takeaway about DeepSeek is constraints breed creativity.
Right.
If you have an unlimited budget, unlimited time, you don't get the most interesting solutions. It's where people have a constraint, whether it's space, power, compute, memory, something that often creates the most interesting solutions because people stop looking at the existing rule book going, this is what people do or how we do it or how it's always been done and go, what if? Or let's try it. And that gets to really interesting things.
Yeah. I mean, think about this. NASA send rockets to the space on compute that is slower than what you have on your phone today, or even your watch, maybe.
I was going to say, yeah, those are leagues above what they use to send people into space.
Yeah, but the physics didn't change since 1960s or 70s to till today,
No.
right? I mean, the physics has remained same. It's just the compute has become very cheap.
Well, the compute has you should know this, but I was a consultant before I started doing what got me here now. And the last project I worked on was United Launch Alliance, and I was part of a team that was cutting out all the IT assets. And at that point, most of the rockets that they were doing were all based off old ICBMs from the 50s, and it was very, very precise engineering, but it wasn't pushing the edges of science or controls. That's one of the things that's blown me away about what SpaceX has done, is they've brought in some different ways to do it, and they're willing to do a test where a rocket may not survive. Before that, it was every rocket was successful, and they just didn't change the recipe. And I think, again, right, you've got to try innovation when you go through some of this and understand to either learn where the boundaries are or learn where the constraints are, so that when you're working to solve a problem, you say, this is the right fit. This is to kind of bring this back into the large language model world. It's like, they're really cool for a lot of things, but they are not a magic bullet.
No,
sometimes you need something very specific, so you go with a more conventional machine learning. Sometimes you got to figure out how you put the right amount of structure around it so that you get the goodness of the large language model interface. Sometimes you use it to create really cool images or stupid videos or stupid songs, but that's not always the right solution either, right? So you've got to look at that as just, it's another tool in the toolkit.
Absolutely. What you mentioned is true. Like, if you think about the back in the days, the mainframes were occupy a whole building, right? And you'd solve certain things, and that has shrunk, right? So I look at LLM, we are throwing insane amount of compute at it because, it's a new field. It hasn't been refined, and we haven't found all the optimizations yet. But it remains a challenge, because if you want to go beyond the 400 billion parameters or 600 billion parameter to maybe a trillion parameter model, is we don't have enough energy out there or the silicon available to build that data center, right? So it has to come from being smarter and being cautious and inventing new ways, optimizing some of these methods, right? So
whether that's hardware or just finding a better way to implement the algorithm or a different solution.
Yeah, better maths, I guess. Yeah, so that's cool.
Cool. Well, I think we've hit a good stopping point for today. I think, we think R1 and the different DeepSeek models are really interesting. We're really excited to talk with anyone who is dropped into our podcast or happens to hear one of the versions. You can go play later. And if you guys have questions about LLMs or big data or those kind of problems, we'd love to have a conversation and see what you're thinking about. We're looking at applying these tools in different ways, and we're always up to see what's next. So